STG with another video. This time we're going to be talking about Boyle's law. We're going to be doing the experiment that only theoretically speaking. Next time I'll try to do the video on the experiment itself with the apparatus and so on. But we've been requested to do Boyle's law and explain the experiment, and we're going to do so. Okay, so we're going to do Boyle's law. Remember, this is in theory how the experiment will go, and eventually we're going to do the experiment and take the readings probably on the weekend. Okay, now there are a few things you need to know and be able to explain for the experiment, because it could be a question. Now, I'm not saying it's going to be a question, but it could be a question, and that is the kinetic theory of kinetic molecular theory of gases, the behavior of gases in terms of kinetic molecular theory. So you need to know that all gases are made of particles that are moving. That motion of the particle increase if the temperature increase, and the space of the particle becomes smaller if the pressure of the volume decreases, and so on. You have to explain all that. I'm not explaining right now, but that is something important to have in mind. Eventually, throughout the experiment, maybe we'll talk about that. Okay, so there is important to know what is an ideal gases. We work with ideal gases. Okay, it is important, and then obvious, because we are verifying Ohm's law. Ohm's law is the most important definition here. Now, Ohm's law states that the pressure of a fixed quantity of gas is inversely proportional to the volume it occupies. So you say here that pressure is inversely proportional to volume if temperature stay constant. That is important. Now, the good about this specific law is that you can also say volume is inversely proportional to pressure. It should be right. If you say it, shouldn't be a problem. My advice, as your teacher, how that your teacher wants you to say Boyle's law. Look at the book, look at your note, how your teacher gave it, and give it to you exactly the same as your teacher. Now, what is the meaning of this one here? Okay, it means that if you increase in pressure, if you increase the pressure of a gas, and if we go here to the summary, the pressure of a gas is the measure of the number of collision of the gas particles with each other and with the side of the container. If you increase in pressure, then that means that the space between the particles becomes smaller, you compress in that one, and then therefore the volume decreases. Or vice versa. If you change the volume of a gas, let's say you decrease the volume, then as the particles are closer to each other and they are moving all the time, it will result in a greater pressure, more collisions per unit time. So that is important to have in mind. Okay, so that is the law. Now, this is the apparatus that most of the places will use to verify Boyle's law. How does it work? Here is a pump there. You have to put A in that side. Maybe if I change the color, it's better. There you can see, there it is. There you put A, we'll see it just now. The air comes, this one is for pressure, this one measure pressure, that one measure pressure, maybe that word. Let's take this one, and much better, much better. Now, the gas that we are looking at is this gas that you see here in this point there up until there. That is the gas we are going to speak about there. Alright, so as you pump air into the apparatus, the pressure is going to change. Okay, this you have a liquid that is going to move up all the way and is going to compress this gas. So the volume of this gas as a result become smaller and smaller. So it become too small up until certain point. That is important. Therefore, this gas is no more. That side will be, for instance, this side. So what is important is that this here is the gas we're looking at, because you look at the apparatus and maybe you start looking at the liquid. The liquid is not important. We're working with the gas. So it's going to be this gas on this side here when it's compressed. This let's say this, to measure pressure, this apparatus here, this little clock, if may say. This one is to measure pressure, but it doesn't start from zero. It doesn't start from zero because it starts from atmospheric pressure. So the number that you will see there is the atmospheric pressure. Okay, so please note, you add or you pump air into the apparatus, the pressure start to increase here, and then the volume start to decrease. So that is basically what is going to happen at first. We're going to go there, but this one is the principle of function of this specific apparatus. It's quite simple, guys. It's quite simple. If possible, this weekend I'll do the experiment to take the readings, because this is actually the explanation. Okay, so now what is the problem here? We have to answer certain questions. Sometimes it depends the experiment. Okay, so the experiment say write an investigative question for this experiment. Guys, what we are going to investigate, we investigating Boyle's law, and Boyle's law is or it shows the relationship between volume and pressure. So that is the investigative question. Now remember, investigative question cannot be a question where the answer is yes or no. So for instance, you cannot say, does volume change, its pressure change? That is wrong, because the answer is, oh yes, it will change. So instead, we are going to write what is the relationship between volume and pressure when temperature is constant. Here you can see that you have the variables involved there, even the constant variable or control. Okay, even those are there. This is the only way of writing a question. Now important, it's a question, and questions have question mark. So there is the only option. No, you can say how does. So let's write the other option, or you can say how does pressure affect volume of a gas at constant temperature. You cannot say yes or no. So those are two options of writing investigative question. We're working with the investigative question. What is the relationship between volume and pressure when temperature is constant? You cannot answer yes, or you cannot answer no. How does pressure affect volume of a gas at constant temperature? You cannot say yes or no. You have to say how does it affect it. Okay, well, you say now as one increase, the other one decrease, and so on. Okay, so that is in terms of investigative question. The next one is the hypothesis. Now the hypothesis, remember, the hypothesis is the answer to that question. All right, so the hypothesis is going to be an answer to the question before the end of the experiment. If the investigation is correctly done, the answer that you're going to give for the hypothesis should be right, because you're supposed to write the hypothesis after you do some research, some investigation. So some people say it could be right or wrong. Yeah, it could, but it shouldn't. It should be right, because before you do the experiment, you're supposed to know what are you proving. You're doing the experiment, okay? So you're supposed to know what is going to happen. So in this case, what is the relationship that we are looking for here? So what we know about this law, we know that, now I need a space, Mr. Gomez, I need a space. Okay, let's write the hypothesis here. I don't want to go too far down. The hypothesis, I'm going to write here, hypothesis. We're going to answer here. We can say that now pressure or volume, it doesn't really matter the order of you saying this one, it should not matter. Let's say the volume of a gas is inversely proportional to pressure when temperature is constant. Now, this is the answer, the anticipated answer, is the first answer. Not necessarily correct, but it should be correct because we know the law. We know what we are going to prove experimentally. We're verifying a law that we know the law already. We're verifying a law. We are not getting a new law that we don't know what is going to happen. So we know, therefore, this one should be correct. Okay, the answer said, the question said, what is the relationship between volume and pressure? When we're speaking about relationship here, or how does, this is the same word. Relationship, how does, is the same thing. Now we're speaking about proportionality. We're speaking about proportionality when we say that. In other words, we say if it's directly proportional or inversely proportional. So far, we have the investigative question, we have the hypothesis. Now, not necessarily this one may be in your experiment. Maybe they don't ask you about that. Identify the variables in the experiment. In this specific one we're doing, we are changing the pressure. We are going to change the pressure because we're going to release the gas that is compressing that specific gas. Okay, so in this case, the independent variable is going to be the pressure. Now, what is the independent variable? Is the variable that you are going to change. In this case, we're changing pressure. Doesn't need to be like that. Okay, so we are changing pressure, and as a result, the volume of the gas is going to increase or change, let's say. So which one is the dependent variable in this case? Is going to be volume. Hey, that's not volume. Okay, now what is the control variable? Now let's be careful here because they could ask you for more than one. For sure, temperature. So make sure you know the temperature is one of the control variables. A demo, yes, there's another one, amount of gas. We're keeping the amount of gas constant. We didn't change the amount of gas. We're only changing the volume of the amount of gas. And this is the first part of the experiment where you have to answer a few questions. And if you can see here, in my experiment years back, there was a lot of marks. There was a lot of marks for that one. Not necessarily it's going to be like that. It could be different. Now it's coming the part when you're supposed to do the experiment yourself. You have to follow the steps to do the experiment. I'm not going to read all that. We're going back here, and here is what I wanted to show you. There is the pump connected. You are adding or pumping air into the apparatus. As a result, this liquid will go all the way up until a certain point. It doesn't matter exactly what point is going. That liquid is going somewhere there, and the volume of the gas we are talking about is this one here. So be careful. That one is the gas we are working with. Okay, so now what is going to happen? You take off the pump and you are going to start opening this what is the name? Okay, so you're going to open this side here of the pump. Remember, I'm Spanish, so sometimes I struggle to get words here. Okay, so you release this one. You release some air that is pressing the volume there, and then as a result, or it's pressing the gas, and as a result, the volume will increase. So say it here, slowly release some of the air. Now be careful if you're doing the experiment yourself, guys. Be careful because you touch this one and all the gas is gone, and then you'll have to pump air again and repeat the experiment. Now, something important as well. As you adding air into the system, you have to give some time. So you add in the air, you arrive to this specific point, then you wait. You wait few minutes, 2 minutes, 3 minutes, because as you pumping, you will notice that this one is getting hot. Temperature is going to change. So you have to wait 2 minutes for the temperature to stabilize again. Now you have to repeat this one a few times, and you're going to record your result. You should have a rubric. You should always have a rubric that give you marks for doing the experiment. for doing the experiment. If you do the experiment yourself, you will be able to do the experiment. Now, these marks are quite simple, not necessarily 3. It could be 6, it could be more, it could be 10, it could be a lot of marks. It depends on the school, it depends on the experiment you're doing. Okay, now this marks for the rubric is for you to be able to do the experiment with the apparatus. So you should be able to do this one without ask a question. You shouldn't be asking questions. Okay, now this is the explanation. I'm gonna try to do the experiment on the weekend and you will see exactly how it works. It's not that difficult. Okay, so those are these marks. If we carry on, this is the table for the result. So now when you see readings here, guys, when you see readings here, you come here and you're going to get readings of volume and reading of pressure. Now, my advice is with your hand on the pump here to release the air, look at the point of the gas, look here, look carefully there, and then you are going to stop the pump, the air for being released when this is in a specific line that you can see, because if it's in between line there is a problem. You're going to struggle to get the readings. Okay, so you make sure you stop the gas from going out to compress this other gas when this one is in one of the lines that you want to take reading, because this measuring pressure here is very easy. There's a lot of lines, there's a lot of a scale, but this for the gas is a little bit tricky. So my advice, look carefully at the gas and stop the gas from leaving the system when you go to a point that you want to take. Remember, you will have to take 6 readings. It could be less, it could be more, it depends on the experiment, guys. So you're going to take readings of pressure and you're going to take readings of volume. Now, this one here is by calculation. This one is by calculation. 1 over volume multiply pressure by volume. Now, for example, from my previous readings I got, one of the numbers I got was 250 kilopascal. You don't have to write the unit if it's in the table. And that one was 16.5 centimeter cubic. Then in this case here, you are coming and you say 1 divided by 16.5, and you get an answer that was 0.061. That is the answer there. And then this is the product of pressure and volume, and you should get 4125. Now, when I say you should get this with this reading of mine, remember you don't have my readings. So this one, these numbers here is by the reading, and this one here is by calculation. And you have to repeat the process. In this case, I did this one quite long ago. I got 225, I got 200, I got 175, and this was real readings. Readings I got in experiment 50 and 125. That is what I got, and this was 18.5. This was 21, 24.5. I'm looking at my readings. Then 29, and then 30. I'm not going to do the calculations. And this was readings I got quite long ago, and I'm not going to do the calculation, guys. You can do it and try it. You can do it and try it. But I want you to point out that this number here, all of them for this specific column here must be the same, approximately the same. Now, approximately, because it's digital, it's real. If it's real readings, they will not be the same. But for instance, I got 4,125, then I got 4,262, and I stayed there in the 4,200 and something. So it was very, very much the same. So it's approximately the same. That is important to have in mind. They are not going to be necessarily 100% the same. At least the numbers are inflated. If it's real readings, they will be more or less the same. Now, that time I did this experiment, I gave 24 marks, but it's not going to be 8. No. 24 marks, but it's not necessarily going to be a game like that. In this case, you should get 1 mark per line here, so you will get like 6 marks. Okay, so I hope it's helping what I'm explaining, guys. I'm trying to do the actual experiment so you can see it. Okay, now from here you have to plot a graph of volume versus pressure. Now remember, generally the independent variable is in the x-axis. So this graph here, you are going to have volume. They are telling you volume versus pressure. So this one, that this second is always in the x-axis. Okay, so here is going to be pressure, and the pressure was in kilo pascal. Do not forget the unit. Volume was in centimeter cubic. And then what I want you to know is that the shape of this experiment is going to be like this. As one increase, the other one decrease, and the other one decreases, the other one increases. This one is the shape you should get in this graph. This is just the shape. I'm not going to do it. You can use my numbers. It's recommended to use my number and practice. You can practice at home. Get a graph paper if you can. Ask your teacher for a graph paper so you can practice. You have enough time to do that. And then plot the result as a graph of volume versus the inverse of pressure. It could be pressure versus the inverse of volume. It doesn't really matter. Remember, I said second one in here, the one that is second, inverse of pressure is here. So it's 1 divided by pressure. And then here is volume. You must write the unit. I am not going to do so, but you must. And if you do this one, the shape of the graph should be in straight line. Straight line, not necessarily starting from 0, but is going to be a straight line. Do not have to start from 0. Let me, you know what? I know my learners. So let's do this. It's a straight, it's a straight line that doesn't necessarily start from 0, but is a straight line. Okay, that is the shape of this graph, guys. I'm helping you with the shape. Now here is coming the analyze the result from the shape of the graph. So you have to look according to what you see in the graph. So what is happening here? And this one is just looking at the graph. Here you have to say first of all what you see. What you see here, that this one is a very briefly explanation. You have to write more. As volume increases, I'm going to write it with arrow. You cannot do that. The pressure decreases. That is what you see in this graph. What you see in this graph here, in this one, you can see that as volume increases, the inverse of the pressure, be careful, also increases. So in other words, in this case, volume is directly proportional to the inverse of the pressure. That's it all there, as you can see it there. Guys, write down the conclusion of the experiment, and the conclusion of the experiment will be the hypothesis. In other words, will be Boyle's law. So I'm not going to write it because I don't want the experiments to be long, the videos, and this video is go already for near 22 minutes, and it's just explanation. Guys, this is the experiment. Now, sometimes they add a question. In some places, they add in a question. Here, I cannot give you question because I don't know which one they're going to ask, but the question is going to be related to Boyle's law. So it could be look at the graph and answer questions from a graph. It could be to draw a graph. It could be to explain certain things, but very easy. It is going to be related to Boyle's law. So nothing to worry about the question. They are not going to ask you a question about Charles' law. It doesn't make sense because the experiment you are doing is Boyle's law. They are not going to ask you a question about Newton's law. They are going to ask you a question about Boyle's law. What question they could ask you? They could ask you to explain this relationship here using a kinetic molecular theory. You have to explain. You say, as the pressure increases, for example, as the pressure increases, the space between the particles becomes smaller, the volume decreases, and that is one explanation. They could ask you to do calculation. For instance, when the volume is, for example, when the volume is 45, what will be the pressure? And then you have to do a calculation. Remember, for the calculation, the formula, I have it here at the beginning of the work. It is the formula to be used here. You need to use the formula P1 V1 equal to P2 V2. How do we use it? Okay, P1, either of them that you uses here, guys, either of those combinations will be P1 and V1, and then you're looking for the second pressure, for example, and I'm not going to finish it. You have enough time to do the calculations yourself. I'm looking here for the numbers in my computer. I don't want to be doing. Okay, there we are. You can say 250, for example, and 16,5, and then pressure 2. I think I said, oh man, I have to go back anyway. 45 is the volume. 45 is the volume. 45 is the volume. What is the pressure when the volume is 45? Quite simple, you're looking for the pressure. Okay, so those could be questions. Now, this is not actually the correct way of doing it. You shouldn't get these numbers from the table. You should get it from the graph. Okay, and we'll speak about that one next time. So guys, I hope the video helped you to understand the experiment and what is going on. If it did, thumb up, subscribe for the channel. I'll try to do the actual experiment next time. Thank you for watching. I'll see you next time. Mr. G here.